Hello, it's Mr. Muller for section 11-2, exponential functions. Alright, so should be kind of a quick lesson. There are two parts that we're going to have for today's lesson. So we're going to have to evaluate exponential functions and then identify and graph exponential functions. And this is something where if we're in the business world or if we're doing things with loans and interest, this is where we'd use some exponential functions. So again, we're looking at things that are exponentially how they grow. So not a multiplying pattern or an adding pattern. They have to grow exponentially. So 2 to 6, you're multiplying by 3. 6 to 18, you're multiplying by 3. 18 to 54, you're multiplying by 3. It's growing exponentially. And this is kind of the formula we're going to use. So if we have something that's growing exponentially to figure out interest or things like that. So we have the function 500 times 1.035% models the amount of money a certificate after X years. How much money will there be in 6 years? So if we're getting something like 3.5% interest here, so there's my 100% interest plus my extra 0.035, so 1.035 interest, and after X years, and this time it said to put in a 6 there. So I'm going to start with my principal, which is 500, times my 1.035%, and then that gets to the 6th power. So then after 6 years, that $500 will become $614.63 if we multiply it exponentially, which is what money would grow. Important that we're noting that it's 3.5%, which is kind of a lot, because if you were actually getting money from the bank, it would not be 3.5%. Kind of the same thing. Function here is $200,000 at 0.98, so really 98%, where in time the year models population of a city. What would the population be after 7 years? So now our population is going down. So if it were staying the same, it would stay at 100%, but now it's going down about 2% a year. So now we're trying to figure out, okay, after 7 years, where is that population going to be? So kind of the same thing, plugging in all those variables, x for or 7 for x, and I can figure out that in about 7 years the population will go from 200,000 to 173,000. Okay, so important if you do anything with, government and city hall or even like schools, they're using this, when they built the new high school in Hastings 10 years ago, they figured, okay, this is what we're growing at, this is how big the school should be so that it could still be a good high school in 10 years when the population grows this much. Here's another one that kind of goes a little backwards. So there's your function, models the width of the photograph in inches that has been reduced by 25%. So now since it's been reduced by 25%, it's still 75% the normal size. Okay, so now if you're going to look at it, that's where the 75% comes from. So since it's been reduced by 25%, it's still 75% the normal size. What's the width going to be after it's reduced 3 times? So again, now this goes from an 8-inch photograph to about a 3 3/8 inch photograph, so 3.375 inches. Some of the other homework problems will just ask you, is it an exponential function? So is it growing by the same multiplication every time? So those you just have to say yes or no. This one from 6 to 18 to 54 to 162. Yes, it's growing exponentially. Same thing here, growing exponentially. Here, not growing exponentially, even though there's a pattern. But from negative 64 to 0 is growing 64. 0 to 64 is growing 64. 64 to 128, growing 64. So yes, there is a pattern there. There is a sequence there, but it's not an exponential sequence. So adding 64 doesn't really count. Same thing here. There's not really even a sequence here. -1, +1, +3. Not a sequence there. So it's not an exponential function. This one is, you're multiplying by a half every single time. So kind of like going with those geometric sequences that we did. Alright, and then the last part is graphing them. So no different than what we did before. You're going to have a formula, so 0.5 times 2, and then your x is going to be that exponent. This is why it's exponential graphing. You're going to pick random numbers. Usually you like to stick with the -1, 0, 1. Kind of get 1, especially along that y-axis of 0. Usually helps. And all of our graphs should kind of be this curved shape right here. So again, just kind of show you some more graphs. So 2 to the x power. Again, picking similar kind of numbers. Again, still getting that curved kind of graph. This one's a -1/4, so that curve is going to be going down. But again, pretty much the same process, where as long as you have a calculator, you're really just plugging in numbers here to look at the graph. Kind of the same thing here through all these as well. And there it is, showing if you have that first number is bigger than 0, your graphs are going to be going up, versus if it's less than 0, then that graph is going to be angling down.